So queues are the next data structure that like is sort of the one that like people always learn. And all this, by the way, you all are getting a crash course. Like normally, object-oriented intro to object-oriented programming is its own like semester-long class, and intro to data structures and algorithms is a semester-long class. And we're sort of doing the highlights, in a week for each. So it is to all of yours credit, that you're diving in and keeping up with all this stuff. Queues are pretty straightforward, right? Like British word for line. If a stack was last in, first out, LIFO, a queue is first in, first out, FIFO. And the example I love to use is it's 1992 and Domino's wants people to be able to order pizza online. Well, we probably want a queue for that because the first person that submits their request to order the pizza, that should be the first person to get the pizza. But of course, we're going to get so many people calling in, or you can actually order a pizza from Domino's by tweet, I think. They do some crazy stuff. Like we're going to get so many people that want to order pizza that we have to keep track of them in order. So it sounds simple, but having a queue, and as you've seen, it's incredibly easy to make bugs or programmer error in programming, or for something to go wrong. And God forbid, once we've written on Domino's online pizza ordering code, if some other programmer messes it up so that the first person ends up last, or someone gets missed or something like that. Now, in reality, if we joined the Domino's software engineering team tomorrow, and they actually have done some pretty interesting software engineering stuff, it seems like, for their pizza ordering, the queue will already have been written. But we may have to use it. So that queue is pretty straightforward. Sort of our interface here for a queue, we want to be able to add something to the beginning. We want to be able to remove something from the end and return that item. And we want to be able to peek. So my vote is let's build a queue. How does that sound? And this one, I think, will be pretty straightforward. And that is the wrong VS Code window. And let me make a file named queue. And we'll take a look at there. And what I want to paste is I borrowed so I just copied and pasted those three methods from here. And the queue is pretty simple to implement, but I think it will be helpful to kind of see my workflow. Like if I was doing an assessment or a programming problem, I'd probably do something like this, of like copying and pasting part of the requirements, adding it in as comments, and just implementing it one at a time. And I am going to ask for some help from you all to build this thing. And in fact, that should be def. And I'm going to get rid of that because we don't need that. So we know that we're going to need a method named enqueue. We know that, and in fact, I'm just going to put this over here as my little dot string comment to make it unhappy. We know we're going to need, and in fact, I'll just write out all of them, even though we're not going to implement them all at once. And do a little thing up here. And for some reason, there we go. let's see what this red squiggly is. Expected indented block. Oh, it wants me to indent my comments. And I have a little bit of a typo over there. Okay, so someone help me out. I need to be able to put the stuff in the queue somewhere. We probably want to list any strong feelings about what we want to call it.
If we're doing both a queue and a stack, would it be confusing to call it base the way we did with stack?
You know, I don't think it's the worst thing in the world. It is not a stack. There is something to be said for consistency, and base is also a short word, which is great. So I'm fine with that. Now we need to add something to our queue, though I feel like I already just got myself confused. I'm just going to call it queue. I apologize. I totally asked and then was like, I'm going to do something else. I could tell my brain was already getting a little confused. I really wanted to just name it like Q because it's like it's the line, it's the Q, but line feels a little weird since we use Q as a class, and it's also a little too close to list for me for comfort. Q frankly is a pain to type, so I'm just gonna do Q. For what it's worth, I think taking the time to name things in a way that help make them make sense to you is really valuable. So now that we've got our Q, how do we want to add something to it?
By using insert.
Insert?
Yeah. Also, sorry if my mic quality sounds horrible. I'm at the pool, but yeah, insert, and I think you would put it at the beginning. So I think you pass in like the 0 index,
Oh,
and then you
awesome.
do that. But I think the index comes first. I could be wrong though.
That sounds great. Let's see if you're totally right. And VS Code gives us some awesome hovering documentation information. And actually, just to kind of talk about how to read this, because this is a bit much, I know. This parentheses in the middle shows that we've got Frank, one sec, I'll just get through this. This parentheses says, hey, this is a method. We see the name of the method. We see the two arguments. Why there's the double underscore in front of these arguments, I don't know. Maybe that's just somebody's syntax for how we define how this method works. But we see these are our two arguments. Index supports index is I can see how that's confusing. My guess is Python has like an index class, but that plain old integers work perfectly fine. Object any makes a little more sense. We have to know that this is the thing that we're inserting into the list, but lists can take anything, and everything in Python is an object. This arrow indicates what the method or the function returns. So this is called a type signature. Or excuse me, this is called like a function signature. The signature is what goes into the function and what comes out. All right, how many arguments of what type and what comes out. And this insert method returns nothing, so it returns none. And Frank, yes, sir, what's up?
This is a question, but I might be getting a bit ahead. Is there a reason why it wouldn't be -1 for like trying to put things at the back of back of the queue?
Like
self.queue.insert instead of 0 would be -1 item.
I think that is correct for adding something to the back of the queue, but I think when we add something, because it's a queue, we want it to be at the front. I see what you're saying. We we may come back to this depending on how we grab stuff from the queue.
Okay.
Because I think I see what you're saying, right? Like if we've got things in here, we should just test this out, in fact, too, to make sure that it's working correctly. Right, because we're hoping, I think that NQ, like if I do NQ, that it then adds like my new thing here. But then I do have to make sure how to, when I'm grabbing the thing from the end, I have to make sure that I'm grabbing the last thing when I DQ. And we may end up using the -1 or like a pop there. I could be wrong. I honestly, I do get easily confused, which is part of why I run the code all the time. So we will see. And I sort of answered my own question here of how are we going to DQ? Let's just do pop. Return an item from the end, remove the item and return it. So let's because in fact we don't pass that item. So we've got NQ and DQ. So let's not worry about peak right now. Let's just do my Q equals QU, a new Q. And then let's do my Q, NQ. First pizza order. Let's NQ a second pizza order. And let's NQ a third pizza order. And what I'm really doing right now is writing a test, which is a good way to think about it. And of course, I actually need to print out what's in the queue. So let's print my queue dot queue. And I suppose I probably should put like an underscore here to indicate that this is a private method. Can someone remind me, is that sort of the convention for like instance variables that we don't want to, that we're not supposed to be touching directly? Well,
We could.
Is that you're talking about like doing that and then having to get her and set her?
yeah, we wouldn't even want to getter and setter because that's what NQ and DQ are. Like, we don't actually want anyone to touch this thing directly. Yeah, here we go. Most Python developers follow naming convention to tell that a variable is not private or is not public, it's private. We start a variable name with a double underscore to represent it as a private variable. So let me go ahead and update this. If that, yeah, I think it's the single underscore. Yeah, the double underscore is kind of like more special. So this just goes to show, be careful just randomly trusting stuff from the internet. This PEP 8 style guide, this is like the official Python style guide for like how we should write stuff. So they describe it really nicely here. Weak internal use indicator, because we can't make it strictly private, and sometimes maybe we want to do something with it. But this way, if someone else reads this, they know that we're not supposed to directly access the queue. And I'm going to directly access it right here, but I know that I'm doing it for a good reason. And I'm getting some squigglies here that do concern me a bit.
I think it should just be .q.
I just renamed it to be underscore q up here. Otherwise, it was that q. It was just q a moment ago, though. though this is a little weird to read. So this is actually great. So my editor is actually giving me a warning. I'm not supposed to be using underscore Q. So this is the great thing about programming text editors. And this is why it's great to like kind of follow conventions. Like, since this is the official Python way of indicating like a protected private variable that we're not supposed to use, my editor is giving me a warning. The program is going to run fine. Python doesn't know, but my editor knows. So this looks about right for the queue where the first thing is at the end. So now if I pop, if I DQ, hopefully we get our first pizza order. So let's see what happens. Because I think, Frank, you raise a good point that there's like two ways to implement this, right? We could implement it where we add stuff to the front and build it out sort of like a line, or if we wanted to, we could, what you were basically saying is, hey, we can use a stack sort of to implement a queue if we want. Or stack-like behavior, really. Because a queue you enter from both ends. So I take that back, it's not totally a stack. So let's DQ. But we have to choose which way we want to go in the list. And let's print the queue again. And let's see what we get. Okay, so this does work correctly. So this is good, but I think that was good to like think about because there's a couple ways to implement this. And it sounds too, Frank, like you might have been thinking like a little ahead on like some variations on a queue or something like that. I don't, was there a particular like variation that you were thinking about, or just sort of like the multiple ways of working with the list?
It was mostly just the multiple ways of working with the list. I was thinking like,
Got
well,
it.
if you're trying to have it first in, first out, wouldn't it just be like you would add things to it to the back instead of pushing them? Kind of like thinking like in JavaScript where you kind of when you add things to an array, they always get added to the back as long as you just without unshifting them.
Got it. Yeah. Yeah. And honestly, I'm not sure off the top of my head if one approach works better than the other. I think they both work well. And in fact, because it is right. Yeah, I do see exactly what you're saying. And in fact, that's why I wanted to go back to the diagram here. Because this did get implemented, I think, the way, let's see. Third, second, first. No, okay, so I did it. Yeah. We can do it either way. And I think I'm starting to confuse myself a little. So I'll just keep on rolling. What questions do people have about the queue now that we've built it? Whether it's about the queue or anything else, or just variations on the theme.
Adam, I have a quick question about when you created the queue list in the instance variable list there. I didn't see it was someone mentioned earlier about not using, like, since you have underscore queue and like in previously when we're defining private variables, we did like if this wasn't on a list, it's just a variable, it would like we did like self underscore queue equals queue, and then you could just use queue to like call that private variable. In this instance, when you're creating a list as an instant variable, is that possible to do, or would you have to create the list as a class variable to do that, or does it matter at all?
Say the bit again about like self underscore queue equals queue. When were you doing it?
Just when we were learning how to work with all the classes. Well, maybe it was when we actually were passing a variable here. Maybe that's what it was.
That was my first thought. That sounds something like this.
Yeah, that's what it was.
Got it. Cool. Yeah. So we totally would if we wanted to. Like for instance, if we wanted to, when we create a queue, it could get a little tricky passing stuff in. We probably don't want to do that because we kind of want NQ and DQ to enforce our order of how it works. Because sort of like as Frank was pointing out, we really get to choose how we use the list, but we do have to make sure that NQ and DQ like use it in that coordinated fashion. And the more stuff that we add to like our Q class, like peak or any other sort of like behaviors, it's just to our benefit to make sure that like that the only way to interact with this is through our methods so that it's always happening the way that we want it. Clarice,
Okay.
yes, what's up?
I'm not sure if this can be answered. And it's also another return question. So like when I wrote the DQ, I didn't see that you put a return statement. And of course it returned, well, when I tried to do it without the return statement, it was just like none. Why does it need the return statement when NQ
Right,
doesn't have a return statement, but it returns the list?
right, great question. I don't think NQ returns anything right now. Let's actually look at, we can actually just do a print statement here with NQ to see what happens. And I think I see what you're saying too, that like, hey, this is still working. It's still modifying my list, even though it doesn't return anything. So let me. Let me in fact comment out all these print statements because I always get confused. Yeah, so the NQ method doesn't return anything right now. What it does do is it does add this item to the list. And so then, like after I've got these 3 lines where I'm adding stuff, and then I have this print statement, and this is what prints out whatever's in that list. And then with DQ, so I just modified it now so it doesn't return anything, and the pop should still work fine. And so what we should see now is this print statement shouldn't say anything, but our list will have gotten something popped off of it, removed from the queue. And let me make sure. I always get confused by print statements, especially on Zoom, to be honest. So I just love commenting stuff out. Okay, so now we've only got this one print statement. It's definitely none. So the way that the pop operation works is it does 2 things. It removes something from the list, and then it returns that thing. So like if I do like removed item, it will be here, and I could do like an F string, removed item is removed item, and then I could do return. So, and actually, let me just run this right now. So pop does 2 things. It removes something from the list and it returns it. And we can capture the thing that it returns here and print it if we want. And the reason that we want the DQ method to return the thing that we got rid of, and this is a really good question because actually we haven't really talked about this much. When you do use a queue, if we take something off the queue, we probably want to do something with it. So it's just sort of a nice, it's just nice for the programmer, for the DQ method to return the thing that we're getting off of the queue, because more often than not, we probably want to use it. So like instead of, you know, this, we can just do that. Does that help explain a bit, Clarice?
I think so. Maybe it's just like a class thing because none is a type that I'm often running into. And I'm like, why are you doing this? But I guess it has something to do with the return statements.
Yeah. Yes, I see. Oh, Megan, yeah, go ahead.
I was just gonna say, like, if you don't have a return statement, Python will automatically return none. Like Python adds in a return statement for you and it always returns none if you don't put one in.
Yeah, exactly. And that is a very good point. I'm glad you explained more, Clarice, because I wasn't even thinking about that. And I totally get what you're saying now, like, where the heck is this none coming from? Yeah, and Megan, thank you. You hit the nail on the head there. Like, for any method or function in Python, if I don't have a return statement, it basically adds in a return statement that returns none. And the reason is basically like consistency, like kind of the way Python is designed, every function or method has to return something. And that's the whole reason that the none, I guess it's a class, but that the none type exists so that we can have, I mean, there are lots of other reasons for it too. But yeah, if we don't have a return statement like this DQ method, we will get none right here. And that is exactly what's happening. Like Python is adding in return none as like as a behavior if there's no return statement. Yeah, great question. And yeah, please, thank you, and Megan, thank you too. I didn't even think to mention that, and that is totally a non-obvious Python behavior. So I think the last thing we've got to implement here is the peak. And for this, we are going to use, we can just use the -1 list index the same way we did before. And in fact, turn the item at the head of the queue. Yeah, Frank, I do see your point, because like especially with like head and tail of lists, it does start to get confusing. Let's go ahead and peek in the queue, and let's just do that right here. And let's just do my queue dot peek, and we should see something. And this looks about right because we're printing out the queue. It's got these two things, and we see the thing that we've decided is at the end of the line. Josh, I see your question. It's a great question. And essentially, we kind of have to decide how we use a list to implement a queue. We can do it either way. I just sort of decided, because that was just where my brain went, that like the thing at the end of the list is at the head of the queue, and the thing at the beginning of the list is at the end of the queue. You know, you do make a really good point, and Frank was mentioning this as well. If we do it the other way, then the 0 index is at the head of the queue, which can make things a little easier. There might be an advantage to one approach that is escaping me at the moment. But we can see that it is relatively straightforward to implement both approaches, whichever one we want to do. And the beauty of the queue structure is that once we've implemented it, we don't care, and we don't care about the list. So we get to make that choice when we build our queue of how we want to implement it. But once it's implemented, then this is what really enforces the behavior. And this is where like writing some tests can be really useful. Because if I suddenly decide I want to change how my queue works and have it store stuff in a list the other way, well, if I have some nice tests to run, then I can refactor it and run the tests to make sure the queue is still working the way it should. What's on people's minds? Questions, thoughts, curiosities? And Matt, yeah, off the top of my head, if we set up Josh's way, something would be different. The NQ and DQ, like these would essentially have to be flipped, and then peak would work a little differently. Like we would insert at the end of the list instead of the beginning, and instead of popping, we would shift or remove the thing from the front of the list. And then for peak, we'd do that as well. So last up, we have linked lists. I'm thinking this might be a good time for what, like a 10-minute break? How are people feeling? Yeah, let's do it. I'd much rather take more frequent breaks so we can kind of use our brain, use our bodies and refresh our brains. I'll leave this up here. Well, I'll show this here just as a preview. We kind of saw linked lists a little bit on Monday, and now we're going to return to them. So in a minute, we'll take a break. We will implement a linked list. And then your assignments for this afternoon are really just re-implementing these data structures that we've done here in class. There's a little bit of variation that we have to throw in the mix, but really just practicing doing these. And then I can give you all like some leak code problems or something like that if you want a bit more. The linked list, there's plenty of good stuff for. So hopefully, I think kind of what we did this morning will lend itself to the hands-on time this afternoon. So let's take 10, and then we'll talk about linked lists.